Hello students, welcome to Uncle. Good evening to all.
Good evening, sir.
Good evening everyone. Good evening Jashi. Good evening Divya. So today we are going to discuss X-ray diffraction and reciprocal lattice. So first of all, I will be discussing the X-ray diffraction. Of course, you are already familiar with this interference and diffraction phenomena from your 12th standard. So those basics, they are going to help you now. So you remember yesterday, while introducing Miller indices, or day before yesterday, I said that we consider that the crystal lattice, it can be assumed to be consist of parallel atomic planes. Remember?
Yes, sir.
So this is one plane, this is another plane, this is another plane, like this. All these are parallel, and these planes, they are made up of atoms like this. This. Okay. So these are atomic planes, means atoms are there. Now what is happening? An X-ray, or you can say electromagnetic wave. So X-ray, it is coming like this, and it is getting scattered. You can say actually it is getting scattered, but you can use the word diffraction or reflection also, whatever you are convenient with. So let us call this ray as ray 1. Okay. And normally this angle is taken as theta. Do you know? This is called grazing angle. Why this is called grazing angle or glancing angle? You might have read this word in the books. What do you mean by grazing? Anyone?
Grazing means like along the field or along the ground that the cows are.
The ray is very much near to the surface. Okay. It is just traveling near to that atomic plane. Means in reality this theta is very small. Grazing means it is moving along just by touching that surface. It is very near to that surface. That is why this word grazing is used. Okay. Clear? Good evening, Durga. Clear to all? Now,
yes, sir.
There is another ray that is coming like this parallel, and that will go like this. Now there will be some optical path difference between these two rays. This is ray 2. Now these two, they will interfere. They will interfere, and accordingly they will give us the diffraction maxima or minima depending upon the path difference. Now how to calculate the path difference? First of all, we will draw one perpendicular from here to here and another perpendicular from here to here. Okay, clear to all? If this is O, this is A, this is B, this is C, then what is the optical path difference between the ray 1 and 2? Anyone? Actually, I'm trying to deduce the X-ray diffraction formula.
AB and BC.
Yeah, very good. It is actually AB plus BC. Means ray 2 is traveling this much additional distance as compared to ray 1. So optical path difference between rays 1 and 2. Can I call this path difference as delta?
Yes, sir.
So can anyone get me the value of this delta now? And
Actually, OB.
this is D, na? Between the parallel plane, this is D, na? DHKL or D. You can call it DHKL or D simply.
Yes, sir.
Then what is the value of this AB and B? And what is this angle?
Theta.
This is also theta. This is also theta. Because
Yes, sir.
Because angle between two lines is equal to angle between their perpendiculars. OB, you can see this OB is perpendicular to this line, and this one is perpendicular to this line, isn't it? Please check. Clear? Clear or not?
So can you please repeat the principle? Okay.
Let me highlight it. This line, you can see this is perpendicular to this, and this line is perpendicular to this one. Okay, so angle between those two lines will be equal to angle between OA and OB. This is the result you know from your elementary level. Angle between two lines is equal to angle between their perpendiculars. Do you remember? Or should I name those sides also? Let us name these also. P, Q. So what I'm saying is OB is perpendicular to OQ and OA is perpendicular to OP. So angle between OP and OQ, angle between OB and OA is equal to angle between OP and OQ. This is what I'm saying. Now you can please check from the diagram. And similarly about OB and OC. Is it clear? Yes?
Yes, sir.
So what is AB from that right angle triangle OAB?
T cos theta.
How? Base will be OA. Because
Yes, sir. Sorry.
base or hypotenuse. So in a right angle triangle OAB, you need to calculate AB, and you know OB, it will be sin theta, not cos theta. So AB will be OB sin theta and OB is D. So similarly, you have BC, D sin theta. So 2D sin theta, please check everyone.
Yes.
Yes, everyone. Now, what is the condition for constructive interference? This is the
Should be the infinite level of lambda.
Yes. Now for constructive interference. Diffraction is also interference. Na? Interference is actually between two different waves coming from two sources. Diffraction is the interference between two waves coming from the same source. That is the only difference. Na? Okay. The path difference should be integral multiple of lambda. Is it clear? So then it becomes 2t sin theta equal to L lambda, and that is nothing but Bragg's condition for diffraction or Bragg's equation. Noted everyone?
Yes, sir.
So therefore, 2d sin theta equal to n lambda. This is Bragg's condition or Bragg's equation. So any doubt from this? Any doubt?
Sir, is the light like the light which gets reflected? Does that is polarized or like it remains the same state as it was before?
There is nothing to do with the polarization in this case. For polarization, there is a different phenomenon altogether. If you want to make the light polarized by reflection, first of all, this is not the light, this is X-ray. There is a difference between light and X-ray. Okay. Secondly, if you want to polarize the electromagnetic wave, then you need to follow that electromagnetic wave at Brewster angle on the surface. Only then the reflected light will be plane polarized. Otherwise, it cannot. But here the theta should be according to Bragg's equation, not according to that Brewster law. That is a different phenomenon. Okay. It may be polarized corresponding to some thetas, but we are not concerned about that. For that, you need to check whether that theta is Brewster angle or not. So there will be only one and one Brewster angle for the given surface, depending upon the media. Clear or not?
Yes, sir.
Brewster angle is tangent, or it is also called polarizing angle. It is tangent theta p is equal to the refractive index of medium 2 to refractive index of medium 1. That's how you can check whether that particular theta it is Brewster angle or not. So Bragg's equation, it is a negative statement. So this is a very important point that I'm referring to. Now, what do you mean by a negative statement? Why I have written this line? Actually, it means that if Bragg's equation is not satisfied, then obviously we are not going to get the diffraction maxima. Okay. It means no reflection. Means no diffraction peak in the diffraction pattern. But even if the Bragg's equation is satisfied, then it doesn't guarantee you that you will be having a diffraction peak in the diffraction pattern. It doesn't guarantee. The reflection may be there or may not be there. We are not writing the word surely. We are saying it may occur. Okay. Means it depends upon other factors also, apart from this equation only. Clear or not? Means if some quantity is related to a particular crystal, they are obeying the Bragg equation, and you are asked that will you be able to get the diffraction peak corresponding to this situation in this lattice? So the answer will be no. It may be or may not be. Okay. We cannot surely say that there will be a diffraction peak corresponding to that. Is it clear?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
But if Bragg's equation is not satisfied, then we can surely say that corresponding to these parameters, there will be no diffraction peak in the diffraction pattern. Then we can surely assert this. Okay. Now, one more important thing related to Bragg's equation or condition. Now see, for cubic structure, if we find DHKL, for cubic case, it is given by this formula, only for cubic. Then what about D, NH, NK, NL? If I multiply each of these Miller indices by this factor, then what is the formula? So it will be like N, H square, K square, L square. This one. So can we write it as D HKL by N? Okay. Now what does it mean? If I write the Bragg equation in this manner, this theta is also corresponding to HKL. That the equation was like this, isn't it? Please check. Now can I write this equation in this manner by bringing N onto the left hand side? And can I write this as? Please check. Because DHKL by N, it is equal to this. This we have proved already. So what does it mean?
First means the maximum.
It means the nth order reflection from HKL plane. Nth order reflection from HKL. It is considered as first order. Now N is 1 over here. Please check. There is no N. It is first order reflection from NH, NK, NL. They are equivalent. I mean to say both these reflections are equivalent. Please check. So this is very important. It means we need not study all the reflections. If we have studied some HKL reflections, then the results for NH, NK, NL reflections, they are already available with us with the help of this formula. Clear?
Sir, what is the nth order reflection from HKL?
This is called nth order. This is called order of reflection. Here,
Yes, sir.
here N is missing, so means it is 1, 1 dot 1. So
Yes, sir.
this reflection was from HKL and order was N. This reflection is from NH, NK, NL and order is 1. Now read that statement that I have written.
Yes, sir.
Yeah.
Thank you, sir. Yes, sir.
So it means if you are doubling each of Miller indices, if you are doubling, it means the second order reflection. Suppose you are having D111, means second order from D111, it is equivalent to first order from D222. Okay, that is second order reflection from 111 is equivalent to first order reflection from 222. From 222. Please check. Clear?
Yes, sir.
Yes, sir.
Now, what do you have in X-ray diffraction pattern? This kind of curve is there. I'm going to make that X-ray diffraction curve. This is the curve between 2 theta and intensity. 2 theta and intensity, and this curve is like some of the peaks are there, like this. Then there is a peak suddenly, and then there is another peak, then like this. These are the peaks. Now, it means the peak positions, they have something to do with theta. This theta is same angle that we have considered in that diagram. Okay. So if we are able to get to theta, we will be able to get theta also by dividing it by 2. So it means the peak positions, you can see, peak positions, they are at different angular positions, different thetas, and they are also having different intensities. Please check. Different intensities are there. Na? So it means we need to notify 2 things: theta positions of the peaks and their intensity. Okay, clear? Now, these positions of the peaks, these theta positions, what do they tell us about the lattice? They tell us about the lattice type. Means how we can get the crystal structure from X-ray diffraction? By making this plot between 2 theta and intensity. And by looking at the positions of the peaks, we can get the information about the lattice type. And what do the intensities tell us about? The intensities, they tell us about the basis. Basis means the atoms. Which atoms are placed at the lattice position and how many atoms? Basis means an atom or group of atoms. No? So we are able to get the lattice type and basis also. And lattice plus basis means, what is lattice plus basis? It is crystal. No?
Yes, sir.
It means we are able to get all the information regarding the crystal structure. Clear? Now, they can ask you numerous questions based on this. Now, with the help of these 2 points, let me ask you one question. Suppose you are asked, there is a sodium crystal and another is magnesium crystal. Okay, suppose complete sodium crystal or complete magnesium. Let us keep it monatomic only. In one crystal, you are having sodium only, and in other, there is magnesium only. So, will there be change in the intensity of the diffraction pattern for sodium and magnesium? Please tell me. Means, will there be difference in the peaks for sodium and magnesium? Because the second point we have mentioned that intensities, they depend upon the basis, and basis means atom or group of atoms. It means corresponding to different atoms, the intensities of the peaks will be different. Okay, clear? So this way you can make the answer by using these 2 points. Clear to all?
Yes, sir.
Now, depending upon whether we are wearing theta, lambda, or you can say the order, there are different kinds of we can say X-ray diffraction techniques are available. Okay, different kind of X-ray techniques are available. And what are the techniques? You can write X-ray diffraction methods. Different X-ray diffraction methods. Now you can see in 2D sin theta equal to n lambda. How many variables are there according to you? How many variables? See, either you can vary lambda.
Lambda, n, or theta.
But n is not in our hand. We can
Yes, n. So lambda and theta.
lambda, theta, and d are there. So either you can vary lambda and then theta, and d means it will depend upon the set of planes. From which set of planes the diffraction is occurring, that will depend upon d. Okay, and of course theta also. Now, if we are taking monochromatic X-rays, monochromatic means single wavelength. Okay, so if monochromatic X-rays are there and they are falling on oriented specimen, many thetas, means orientations. Means we have made the powdered form of the specimen. Obviously, when we make the powder of some solid, so small grains, they will be oriented in different random directions. Huh? And this method is called powder method. This method is called powder method. So in this method, what do we have? Lambda is fixed, theta is variable. Theta variable. Na? This is what we have in powder diffraction method. Now, either we can have panchromatic X-rays. Panchromatic means, or you can say polychromatic, means varying lambda. Lambda is variable. So if you are varying lambda means you have to fix theta, because you cannot vary both the quantities. Okay, and this is called von Laue technique of X-ray diffraction. Laue method or Laue technique. Okay, clear? Lambda variable, theta fixed. And again, the third type can be, again, if we are keeping lambda fixed and theta is also fixed, but if we are rotating the crystal, there is only one single crystal. We are not having the specimen in powdered form, but we are varying theta by rotating that crystal in different angles. So if you are rotating some objects along different directions, even then there will be certain set of planes which will correspond to X-ray diffraction at certain angles, and some of the planes will not correspond. Okay. So this is called rotating crystal method.
So can you please repeat?
When you are rotating the crystal, are you going to get the same set of planes which are facing the X-rays?
No.
It means you are varying the set of planes, and for different set of planes, you will be getting different thetas.
Okay.
Means theta is variable, you are rotating theta. And depending upon this equation, because lambda is fixed for a particular theta, only particular set of planes they will satisfy this condition, and they will give you the diffraction pattern. Okay? Clear?
Okay, sir. Thank you.
Means you are rotating the crystal with the hand. Some kind of handle is there in that apparatus, and you go on rotating. And the crystal is placed in the middle, and then there is a film, just like that X-ray film, black film. It is placed all around the specimen like this. So there is a specimen crystal, and there is an X-ray film all around this, so that we are able to identify the spots because of the X-ray. You will be getting the spots like this. Okay. So then by looking at those spots, we can get the measure of theta. Clear?
Yes.
Now let us discuss some of the numericals based on this X-ray diffraction. Lots of questions have been asked based on X-ray diffraction only. See, first one. Monochromatic X-rays of wavelength 1 angstrom are incident on a simple cubic crystal. The first order Bragg reflection from 311 plane occurs at an angle of 30 degrees from the plane. The lattice parameter of the crystalline angstrom. 1 √3 IIT Jam 2009. You have already solved it, Tarun. Is it?
Yes, sir.
Correct. Your answer is correct. Now, first of all, we have to find D. And for that, HKL they are given. And A is also known to you. A we have to calculate. Sorry. A we have to calculate. Lambda is given, theta is given, and HKL is given. Now, what is B311? It is cubic, simple cubic. So, for simple cubic, we have this one. A by √11. So, using Bragg's condition, what do we have? 2D sine theta, that is 2D311 sine 30. First order, 1 into 1 angstrom. So 2 into A by √11 into half equal to 1 angstrom. So these 2 and 2 they will get cancelled. So A is √11. This is the answer. Please check. Clear?
Yes, sir.
Very simple. You just need to know the Bragg condition and this. Very easy as per IIT Jam standard. That's why I always say that this subject is very scoring. If such a question comes in the exam, very straightforward. No? So almost every year they are asking one question from this topic. Yes. Please answer in the chat box only. Very good, Arun. Again, similar to the earlier one, HKL they are given. A is also given. Lambda is also given. And first order. So you have to find theta. So B111 is A by √3 So according to Bragg condition, how much are you getting? Sin theta?
0.499.
Approximately 0.5. So theta is sin inverse 0.5 or sin inverse half, that is nothing but 30 degree. Yeah, come here. Please check everyone. Clear?
Yes, sir.
Yes, sir, I'm correct. Again, HKL they are given, wavelength is given, lattice constant is given, and first order n is also given. So theta, again theta. Yes, Yali, very good. Yes, Satish, correct. This got cancelled with this one. So that's why root 2 by 2 into 2. So then root 2 got cancelled with one of the 2's in the denominator. Yes, Tamya, correct. So B option again. So you can see all are very easy. Please check. Clear?
Yes, sir.
Yes, sir.
Okay. No, one question of novel kind was there with me. So all these were easy, but they may ask you the question in this format also. Based on maximum order of reflection. One was, let me. Yeah, this one. This is not TYQ, but important one. X-ray of wavelength 1.2 angstrom is incident on a single cubic crystal of lattice. Maximum order of from the crystal. Means n, the max value of n. Now what do you have from Bragg's law? And n is given by this one. And now you are looking for max value of n. How you can get max value of n? Of course, you cannot vary lambda over here. Lambda is fixed. But what you can do is you can get sin theta maximum, and that is 1. Isn't it? And D is related to A in this manner. Now, what is the max value that D can have according to you?
001 HKL as 001. So A.
Corresponding to 100 or 010 it cannot be greater than this A value. And sin theta max is 1. So it becomes 2A by lambda. Please check this step, everyone. D max is equal to A. Is it clear? Because HKL, all of them, they cannot be 0 now. At least one of them should be 1. So the max possible value that D can have is A. Okay. Now lattice constant is given, that is A is given, and wavelength is also given. So now you can put these values. So can I write it as 2 into 32 by 12? 6, how much? 5.33.
Yes, sir.
But n has to be integer. No? So we will say that it is fifth order because it is not able to reach up to the sixth order plane. Okay. I will show you with the help of the diagram. Now, what do you mean by order? Let me tell you. This is first set of planes. This is second, third, fourth, fifth, sixth, like this. X-ray is coming. It is getting reflected. This is called first order. And if it is going to the second plane, second set of planes, it is called second order. If it is going here, this is how the order is defined. Okay. But in this case, the X-ray, it is not able to go up to the sixth plane. It is able to reach up to the fifth plane and a little distance more than that. Clear? Because the medium is getting denser and denser, na? It has to pass through so many atomic planes. And because of the diffraction, it will go on becoming weak in intensity, this X-ray. Clear? So that's why we always take n equal to 1 whenever it is not referred in the question. Because whenever you for X-ray on the surface of the crystal, the very much possibility is there, it will be getting reflected from the surface only. Na? Because only after passing through the surface, it is able to reach the planes below the surface. Na? So obviously there will be reflection from n is equal to 1 set of planes, always. It cannot happen that it is leaving those set of planes and getting reflected from the second set of planes. It cannot happen so. Na? Clear? Is it clear or not?
Yes, sir.
So that's why n is 5. We cannot take it to be 6. Always the lesser order because it is not able to reach up to the sixth set of planes. That's why. Clear to all? So now we can relate these to other things also. Let us see how. But first of all, let me derive 3 formulae for you. X-ray wavelength for different sources. Different sources means there may be different sources used for X-ray diffraction. And we always know that the material particles, they are also associated with the waves. Can I call this as radiation wavelength rather than X-ray only? Because for the material particle, it will be matter waves, not the usual X-rays. Okay. Now, for X-rays. Now, X-rays are the electromagnetic waves. So the formula for wavelength will be Hc by E. Okay. Now, suppose I want to substitute this energy in electron volt. What I have to do? Rather than having this energy in joule, if I'm having this energy in electron volt or kilo electron volt, then what I have to do is I have to put the value of kilo electron volt, isn't it? Because now I will be directly substituting the value in kilo electron volt. I won't be substituting the value of kilo electron volt because I have already taken that value. Okay. Now, can you solve this one? You need to tell me the exact value up to 3 decimal places.
12.424 10 raised to power
424
into 10 raised to power
minus 10.
minus 10.
Which means it is 12.424 energy in kilo electron volt. So now you need to remember that here the energy should be in kilo electron volt. This is the formula that you can remember directly. Okay. If you know the energy of X-rays, then you will be able to get the wavelength directly by using this formula. Now let us do the same thing for neutrons. And we know that neutrons are the material particles. And for every material particle, the wavelength is given by de Broglie relation, h by p, where p is momentum. And how p is related to energy? By this formula, because energy is p square by 2m. So 2m is equal to p square. So 2m square root is p. Is it? Now let us again substitute the values. Neutron. And let us again consider that energy value is in electron volt. So I have already substituted the value for 1 electron volt. Now please solve this one. How much? So you need to solve this factor. And this will come out to be in meter, and or accordingly you can convert it into angstrom. That will be more convenient to remember.
Two point 866 to 10 raised to power minus 10.
0.2866
Yes, sir. I'm sorry.
angstrom. Please note down everyone and kindly check. Are you getting the same answer? So can you use neutrons for crystal structure determination? Can anyone tell me? Can you use neutrons? Electrons are also the material particles. So for them, the formula will be like this. Instead of the mass of the neutron, now we are having the mass of the electron.
15.22.
15.22? Is it? I don't think so. Please check.
Is it 12? 12.27.
Yeah, 12.28. This should be the value. Is it?
Yes, sir. Yes, sir.
And you can also find this value written in some of the books. This way. Because the square root of 150.8, it will be around this one. So you can remember whatever way you are convenient with. Okay? Is it clear?
Yes, sir.
Now you have not answered my question, any one of you. Can we use neutrons? For surface structure determination, we cannot use neutrons because neutrons are the neutral particles. If we want to get the idea about the surface structure, then we need to use the X-rays. Neutrons, they will penetrate inside the crystal as they are neutral, and they are not going to interact with any of the ions or the charged particles. Okay? So for inner structure, inner view, we can use neutrons, but for structure determination, we cannot. Okay? That's why we need to rely upon the X-rays. Crystal structure. Structure means from how it looks from outside. Na? The shape of the crystal. Clear?
So can you just repeat?
There is a crystal, and you want to know its shape. So can you just fall a beam of neutrons in it and get the structure? Neutrons, they will penetrate inside the crystal. They will not interact with anyone on the surface. What do you have at the surface? Atoms are generally ions. Na? They are positive or negative ions. So because neutrons are neutral, so they are not going to interact with the charged particles. So they will penetrate inside. So they can provide you the inner information of the crystal, not the surface information. But you require the surface information in order to get the structure or in order to get the picture of the shape, how it looks. So that's why you use X-rays rather than neutrons. Okay? Clear? Clear?
Yes, sir.
Yes, sir.
Neutrons, they provide you the inner view, what is inside that crystal. If you want to get the idea about the inner one, because X-rays, they will not be able to penetrate inside. As we have seen in that one question, that the maximum order reflection, it is limited because the intensity will keep on going down. Okay, so for that the neutrons are used in order to get the idea about the inner picture or inner view. Okay, clear? Now, more questions based on X-rays and little tricky one and advanced one, because now we will be combining at least 2-3 formulae rather than just that Bragg condition and DHKL. So this is one step ahead from the questions that we have discussed from PYQs. So now we have to calculate the radius, and for that you should know the structure of the crystal lattice, in which cubic form it crystallizes. Do you know? In which cubic form it crystallizes? FCC. You need to remember this. And when we say FCC, therefore, a relation between atomic radius and the lattice constant will be this. There is something wrong. This was for TCC. Na?
Yes, sir.
It should be A by 2 root 2. Na?
Right, sir. It's 8.
Yeah. So R is A by 2 root 2. Now, let us calculate D220. Can I substitute for A over here? A is 2 root 2 R. Na? So you can see we are getting D220 equal to R. Let it be number 1, this be number 2. Now, according to Bragg's condition, 2D sine theta and lambda. So 2R sine 32 degree. Order is not given, so obviously it is first order. So R will be so little bit lesser than that 1.54, because if it would have been 30 degree, it is exactly equal to 1.54. Now little bit less. Please get me this value.
So does all the materials crystallize into FCC structure?
Not all the materials, almost 80% of them, because it is the most densely close packed structure. Na?
Okay, sir. So if we don't know, then what's the best?
You need to remember. Then some of them they may crystallize in PCC also. Na?
Okay, sir.
So you can remember whatever structures they are given in your identical material. Na? So they are going to ask you from that only. Means the common, for example, iron. Let me tell you the materials. Iron, copper. It is much widely used. Sodium. Daily life. Those you make use in daily life. Na? Iron, copper, sodium is there. Lead also is there. Okay. These, and of course diamond is there, like this. Gold, silver. Okay. The things that you make use of in your daily life. That is the technique, because they are going to ask you from those things only. So the answer is coming out to be 1.45 angstrom. Please check everyone. Clear?
Yes, sir.
Yes, sir.
Now, another important question. A BCC lattice, whose lattice parameter So please try to solve this one. Just get me that lambda value, then afterwards I will tell you how to find the potential. See, first you can calculate T11. It is a by root 3. Now you can make use of drag condition. So 2 into a by root 3 sine 18. N is obviously 1. And then lambda we have to calculate. So lambda will be 2 by root 3 into 3.44 angstrom into sine 18. What is this value?
Sir, 1.22 angstrom.
22, and then what is afterwards? Another decimal.
364.
1.2236.
Yeah.
Kindly check. It should be 1.227, what they have given. Now for electron, we have done that. Now if energy is in electron volt, then potential is in volt. No? So can I write this? This should be 1.227 something. Anyone else has solved this lambda?
Yes, sir, 1.2274.
Okay. So 1.2274 and approximately these two are equal. So 10 is there, so root V is 10. So V is 100 volt. So this is the accelerating potential of electron V. Because we have already taken the value of this E. Na? So electron volt means potential is in volt. Is it clear or not?
So can you just repeat that last point?
If energy is 1 electron volt, then what is the potential? If
By
energy,
dividing it by the charge of the electron?
no. Charge of the electron is E only, na?
Yes, sir.
This E is what? This is the charge only, na? If you divide it by E, you will end up getting P only, na? That's what I'm saying. If energy is in electron volt, then what will be the potential? It will be volt. Okay?
Okay.
Now I think it is more appropriate. V in volts. Because when we divide it by E, E and D will get cancelled and we are left with volts only, which are the units for potential. Always remember, if how do you define 1 electron volt? You always say that it is the energy acquired by the electron when it is accelerated through a potential difference of 1 volt. So in case of electron, whatever voltage you are having, it is transformed to the same value of energy in electron volt. That's it. Okay. So even if you solve for energy, you would have got this energy as 100 electron volt. So if energy is 100 electron volt, then means potential is 100 volt. That's it. Okay.
Yes, sir.
From the following data, calculate the wavelength Will you try this one? Now again, first you have to find lambda, and then you can make use of the relation lambda equal to h upon mv, and from there you can get the velocity of the neutron v. Spacing is already given. No need to solve now. Direct spacing is given. So 2d sine theta equal to n lambda. This. Now you can make use of this formula. And from here, v is h upon m lambda. You can get the velocity. Neutron. Please calculate. Yes, anyone? Yeah, around 1033 something. Everyone, please check. Are you getting the same value? 103233 around this. Is it?
Yes, sir.
So clear, na? That's how they can extend this X-ray diffraction numerical to another level by connecting lambda to other values, either to energy or potential or velocity. Or they can reverse this one also. In the beginning, they can provide you the velocity or the energy, and from there you have to get lambda, and then you can make use of that Bragg condition. Okay, let us see one numerical based on this. Electrons are accelerated to 344 volts and are reflected from a crystal. The first reflection maximum occurs when glancing or grazing angle is 60 degree. Now potential is given, so you can make use of this electron, 12.28 by root V angstrom. From here you have to calculate lambda and then of course the spacing. So what is lambda coming out to be? Yes, anyone? So we have to calculate P, na? First reflection maximum. What is lambda?
0.6.
0.6. Then always get up to at least 2 decimal. Is it 0.6 exact or some other decimal places are there?
0.66.
Yeah. Always remember, you have to get it up to at least 2 decimal, not less than that. So D is 0.66 angstrom by 2 sine 60. Sine 60 is root 3 by 2. So it is 0.66 by root 3. How much? 0.38. Let me check the answer. Yes.
0.38.
Yes, 0.38 angstrom. This is the spacing. One more. Done, everyone?
Yes, sir. Yes, sir.
Calculate the angle of first order. Thermal neutron, whose kinetic energy is given 0.02 electron volt, undergo diffraction from a crystal plane 100. The Braggs to angstrom. Again, we need to find lambda. And for neutron, the formula was 0.26286 and energy in electron volt. No? This was the formula. Can you please solve this one? What is lambda?
2.022.
Let me tell you how you can calculate it. Actually, you can write it in this manner. And this will become root 2 into 10 to the minus 1. So this will become 2.86 and this will become 1.414. So approximately 2 now. Or you can get the exact value also. And theta is sine inverse 1 by 2. And this is nothing but 30 degree. Na? So you can get the exact value, okay? So I'm not calculating this time. That's why I've written 2. Nearly 2. What is the exact one? If you have calculated
2.0268 angstrom.
2.0268. So you can use this one. And there will be a little bit difference from what is this value then? Point. It will be a little bit more than 0.5 this time. So angle will be a little bit more. How much? 0.5 something will be there.
Yes, sir. 0.5067.
Okay. And what is sine inverse of this? It will be a little bit more than 30 degree. Minute difference will be there. .36. Is it? Please check, everyone. Is this the answer you are getting?
Yes, sir.
So this was all about X-ray diffraction. So tomorrow we will discuss about reciprocal lattice. Why do we require reciprocal lattice, and how to get the reciprocal lattice vectors from the direct lattice vector, and what are the particular planes that can give you reflection in simple cubic, BCC, and FCC, and all. Okay. So okay, beta. Bye bye. Take care.
Bye, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.